everyone, and welcome back to another professional prep video. In this video, I'm going to be talking about trig derivatives, also known as the derivatives of trig functions. We've explored how to find derivatives of polynomials, and that does cover a lot of what we will be seeing. But now I'm going to talk about some trig derivatives that we might see, that we might need to take the derivative of, some trig functions. So first I'm going to define all of the derivatives, and then I am going to do out an example or two, just so that we can see how it's used. So let me first start. I'll get my pen there. Alright, so I'm just going to go through each of the trig functions and their derivatives. So the derivative of sine x. And these are just ones that you'll probably want to memorize. That would be the best way, especially if you need to know this for any sort of test or exam. You'll want to have these memorized because there's really no easy way, I'll say easy, to derive them like straight on exam. But the derivative of sine is going to be cosine. And what I'm going to do, I'm just going to bring down the whole derivative sign so I don't have to keep writing d over dx. But each of the things I'm about to write are derivatives, so keep that in mind. The derivative of cosine x. Well, sine was cosine, so shouldn't cosine, the derivative of cosine, have something involved with sine? And that is absolutely correct. The derivative of cosine is negative sine x. And now let's talk about some of the other functions. Let's go into some tangent. The derivative of tan x, and remember the d over dx is brought down to be in front of each of these. The derivative of tan x is actually going to be secant squared x. Secant as in the reciprocal of cosine. And the derivative of, let's continue with secant. The derivative of secant x does have tan involved, so that's the nice part if you're trying to remember these, but it also actually involves itself. Secant x, tan x for the derivative of secant. And we have a couple more. And that is going to be our first one, dx of, and what are we missing? Well, we are missing cosecant for one, and we are also missing cotangent. And those two also relate to each other in a way. Derivative of cosecant, CSC, is going to be negative cosecant x times, well, this is where cotangent also gets involved, times cotangent x, and let me bring down that d dx of our last one here, which is cotangent x. And the derivative of cotangent x is none other than negative cosecant squared x. So please don't mistake these c's for parentheses, because they are not. So yeah, there you have it. Those are your trig derivatives. So like I said, it might be best to memorize these, but there's your full list. A good way to help remember is if the function starts with co, for example, cosine, cotangent, cosecant, it has the negative to start out its derivative. And if it doesn't, then it has a positive. So that's just something to get you started on memorizing them. But other than that, they aren't that bad to memorize. Now what I want to do a couple of problems, just so that we can make sure we know how to actually apply some of these derivatives. So I'm going to do one simple one and one involving some chain rule. which we also have a video out there for. So please watch that video on chain rule. So let's say we need to find the derivative of, you know what, let's do both chain rules. Or actually, no, we'll start out simple. Say we need to find the derivative of 3 sine x. Well, this is going to be simple enough. By the constant rule, that 3 can stay out in front. If you forget the constant rule, use product rule and you'll get the same result. But it's easier to just remember that the constant can stay along for the ride, stay out front. And then we look back at our chart. The derivative of sine is cosine. So simple enough, we're going to get 3 cosine x as our derivative for 3 sine x. So there's a simpler example for us. And let me do a somewhat tougher example, I guess. Still not that bad, but amp it up a little bit so it involves some chain rule, just so that we can get a look at one that does. Say that we need to find the derivative of 3 secant, and instead of a regular x, let's put in a 2x. So now all of a sudden, 3 secant 2x becomes a composition. And what do we need to remember about compositions? We need to use chain rule in order to find their derivatives. So now we're talking 3, and then the derivative of secant is secant x tan x. So now we're talking 3 secant 2x. 3 secant 2x tan 2x and multiply by the derivative of what's inside. So times the derivative of 2x, which is just 2. So that's how we use our chain rule there. And this can be simplified because we have that 3 times 2. So it's just going to be 3 secant 2x tan 2x. Sorry, I could have chosen a smaller example, but we need to be prepared to see any sort of derivatives. So there's an example with chain rule. So that's definitely the tougher of these two examples, but nonetheless, you need to know how to do all of them. Sorry about the handwriting there, but yeah. So that's all I have for you for this video about trig derivatives. But please email or leave a comment if you have any questions. And if not, I will see you for our next video, which will be about derivatives of e to the x and natural logs. So we're going to touch on some exponentials and some logs in our next video. Thank you, everyone. Please make sure to subscribe.